This video is for Algebra 3 Notes, Unit 2 Quadratic Equations, and it's on Section P.5 Factoring. So the first factoring we're going to look at is greatest common factor. Most students say that this is the easiest factoring they've done, but they usually forget about it and have to be reminded. So this 3x squared plus 12x, I'm looking at what's common, first of all, with the numbers 3 and the 12. Common term is going to be 3. Then I look at the variables, x squared and an x. The common term is going to be x. That's my greatest common factor. It's the largest I could take out of both terms. Then I need to write something that's left inside here. So I have 3x squared, and if I divide that by 3x, I'm left with x. Plus, if I take 12x and divide it by 3x, I'm left with 4. And then I would check by multiplying. So 3x squared plus 12x. I'm going to repeatedly say check by multiplying. The next one is a greatest common factor, but it might be a type that you've not seen before. I have x squared and then parentheses x plus 3 minus 4 and then parentheses x plus 3. So this x plus 3 is connected to both of these terms, the x squared and the 4 by multiplication. So it's a factor. So the greatest common factor is going to be this x plus 3. When I take that away from the x squared, x plus 3, I'm left with x squared. And when I take x plus 3 away from the negative 4, I'm left with negative 4. In Algebra 2, you also then continued factoring. Once you factor something, you continue to look at it and see if it can be factored more. This one can be. This x squared minus 4 will factor again. It's a difference of squares. So I'm going to factor x plus 3, x minus 2, x plus 2. And I would check it by multiplying. So the next is grouping. It's a special type of factor, greatest common factor, and you may or may not have seen it before. But what I'm looking at is it's a polynomial. It's got 4 terms now. 1, 2, 3, 4. I've got them in order. X cubed, x squared, x, and constant. I'm going to group these together by looking at the first 2 terms and factoring that greatest common factor. So the greatest common factor is going to be x squared. If I factor out an x squared, I'm left with x plus 5. And as always, check. X squared times x is going to be x cubed. X squared multiplied by 5 is 5x squared. Then I'm going to look at these 2 terms, negative 3x and a negative 15. Common factor is going to be negative 3. So I put a negative 3 here. And I'm going to be left with x plus 5. Check again, negative 3x, right there. Negative 3 times 5 is negative 15. Now this is a greatest common factor. This x plus 5 is common to both of these. So I'm going to write x plus 5 and x squared minus 3. This does not go any further. That's where it stops. Check by multiplying. The most common factoring that we really do are usually with trinomials, and there's more patterns with these. And I like patterns. This is one reason I like math. So I'm looking at this, and I've got 3 terms. So it's a trinomial, 1, 2, 3. Usually it has an ax squared, a bx, and a c. All of these have that. But in the factoring, if both signs in there is positive, when you factor, you're going to have both terms that are positive. If the first term is negative and the second term is positive, when you factor, both of the parentheses are going to have negative signs. And then the last group, you have a minus c in both cases. One's got a plus bx, one's got a minus bx. That's irrelevant. It's this negative c that changes it so that one of these terms has to be positive, one has to be negative. So the way most of you were taught when you're looking at this is you taught, well, okay, let's look at the factors of 12. So I want to multiply numbers to make 12 that add up to 7. So I always start with 1. 1 multiplied by 12, they add up to 13. So I know that's not good. I could also have negative 1 multiplied by negative 12, but because both of these are positive, I know I don't need negatives. I need 2 positives. So 2 multiplied by 6 adds up to 8. That's not what I want. I want them to add to 7. 3 multiplied by 4. Well, 3 multiplied by 4 adds up to 7. This is the one I want. So when you factor it, you basically have x squared plus 3x plus 4x plus 12. This 3x and this 4x is where I get my 7x. But now I can factor by grouping. Factor x squared plus 3x, I can take out an x, and I'm left with x plus 3. 4x plus 12, I can factor out a 4, and I'm left with x plus 3. So now my common term is this x plus 3, and x plus 4 is what I had left. And some of you are going to go right to this without doing all the steps, and that's fine. Most of you should be able to get to that level eventually, but you're going to have to be able to learn to factor quickly and accurately. So my next example has an x squared minus 8x minus 20. So this is different. I have a minus sign and a minus sign. When I look back up the patterns, as long as the last term is a negative, I know I'm going to have two different signs. One's positive and one's negative. So that makes a difference. I'm going to put a negative 20. I want to multiply two things to make a negative 20 that add up to negative 8. So I could have a negative 1 times a positive 20, but that adds up to 19. So I could try a positive 1 times a negative 20. They multiply to make negative 20, they're going to add up to negative 19. Well, now I can kind of see, I know I want a negative number here. So when I do my positives and my negatives, I want the larger number to have the negative. So I'm not even going to worry about going through all the factors. I'm going to shorten it up some. So I could have a positive 2 times a negative 10. Oh, there's my negative 8. I didn't have to go too far at all. So then when I factor this, I get x squared plus 2x minus 10x minus 20. Right here, positive 2, negative 10 makes my negative 8. I factor by grouping, so I have x plus 2 minus 10, x plus 2. So x plus 2 is one factor, x minus 10 is the other factor. And when you're doing factoring, it doesn't matter the order. I could have easily said x minus 10 multiplied by x plus 2, because when you're multiplying something, it doesn't matter if you multiply 2 times 3 or 3 times 2. Products, it just doesn't matter the order you multiply in. And I would check by multiplying. Now, these examples, I say a would be equal to 1, meaning I have an x squared for both of these, and the number that's in front of that x squared is a 1, so I don't write it. So the next problems, there's going to be a different number other than 1. A is going to be a number greater than 1. So the first example I have is 3x squared plus 14x plus 8. Well, it makes it a little bit easier for me because I know I have two plus signs, so I'm only dealing with positive numbers. So the first step I'm going to do to figure out what I need to multiply by, get my factors of, I'm going to multiply this 3 times the 8, and I'm going to get a 24. So I have 24, and I want to add up to be 14. So this is where I'm going to get my product. It does make a big difference if you don't do that. Since I want all positives, well, I'm going to start with 1 times 24. That makes 25. I'm going to have 2 times 12. Oh, that makes 14. That was even easier yet. I just had to go one more step. That's the one I want. So now I've got this 3x squared. I've got 3x squared plus 2x plus 12x plus 8. This 2 plus the 12 gives me my 14. So now I can factor greatest common factor. Out of 3x squared plus 2x, I've got x, and I'm left with 3x plus 2. From here, I can take a 4, and I'm left with 3x plus 2. And don't believe it just because I said it. Always double check my work as well. 3x squared plus 2x plus 12x plus 8. 3x plus 2 is my common term, and x plus 4 is what I had left. And I would check by multiplying. And the last trinomial that I'll do, I have a 4 as a leading coefficient. So I have a is equal to 4, but I have a positive and a negative. So I know I'm going to have one of my factors is going to be positive, one is going to be negative. So I'm first going to multiply here, and I get negative 60. So I want two terms that multiply to get negative 60 that add up to 4. So I could have negative 1 times 60. That gives me a 59. And in this case, I want a positive number. So when I'm putting my factors together, I'm going to keep the larger term the positive. So I'm not even going to worry about a positive 1 and a negative 60, because that's going to give me a negative 59. So I'll do negative 2 times 30. That gives me 28. That's not it. Negative 3 times 20. That adds up to 17. That's not it. Negative 4 times 15. That gives me a positive 11. Still not there. Negative 5 times 12. That gives me a positive 7. Negative 6 times 10 gives me a positive 4. Were you getting worried? Because I was getting close to the end and I was running out of factors. There were no more factors after that. So those are my terms I'm going to use. So I have the 4x squared minus 6x plus 10x plus 4. No, I'm sorry, not plus 4, minus 15. I'm looking at the wrong place. Minus 15 is up there. Negative 6x plus 10x gives me my 4x. I'm going to factor greatest common factor from here, and I get a 2x. And I'm left with 2x minus 3. I can factor a 5 out of here, and I'm left with 2x minus 3. So my common factor is this 2x minus 3, and I'm left with 2x plus 5. Check by multiplying, I get 4x squared plus 10x and a minus 6x. Plus 10 minus 6 gives me my 4 minus 15. So I factored it correctly. The next one is another easy one, but students tend to forget it. It's a difference of squares. So what you've got here is you've got a binomial, two terms only. And it's a difference. You have to have a subtraction. And you have to have perfect squares, meaning the square root of x squared is x, the square root of 25 is 5. So if you look at this pattern I have up here, a squared minus b squared, you're going to have the square root of a squared and the square root of b squared in both places, one plus and one's minus. It doesn't matter the order. Out of habit, I almost always put the minus sign first. Every once in a while I try not to do that. It's just habit for me. So when I check this, x multiplied by x is x squared plus 5x minus 5x minus 25. It's kind of like conjugates. Those are always add up to 0. So here, same thing, it's a difference of squares. The square root of 64 is 8, and the square root of x squared is x, so I have an 8x. The square root of 9 is 3, and the square root of y squared is y. So I have a 3y and a 3y. It doesn't matter which one's plus. I'll put a plus there and minus there, but one's got one sign, one's got the other. And you can check by multiplying. Perfect squares trinomials, you don't have to recognize perfect square trinomials, but if you do, it makes your life a little bit easier, makes your work a little quicker. So you've got this pattern here. Perfect square at the front, perfect square at the back. So here, perfect square at the front, perfect square at the back. It's always a plus sign in front of the b squared. And if you take the square root of the first and the square root of the back and multiply them together and double it, you'll get the middle term. So square root of x squared is x. Square root of 49 is 7. X multiplied by 7 is 7x, and if you double that, you get 14x. This is a minus sign, so this is going to be a minus sign, and this is squared. And then just be careful. Remember that this is saying x minus 7 multiplied by x minus 7. So x squared minus 7x minus 7x plus 49. That's where I get the negative 14. If you don't recognize a perfect square trinomial, you can just factor it like a regular trinomial. So here's another perfect square. The square root of 4x squared is 2x. So I have a 2x. Square root of 25 is 5. Both of these are plus signs, so there's going to be a plus sign here, and this is squared. So this is saying 2x plus 5 multiplied by 2x plus 5. Gives me 4x squared plus 10x plus 10x plus 25. So that is correct. And the last factoring we have is cubes. A pattern here as well. You have to have a cubed plus b cubed. So a cubed is x cubed, b cubed is 125. So I'm going to put, instead of a plus b, I'm going to put x plus 5. Then I want x squared. A is x, so I want x squared minus ab. A is x, b is 5, so I want minus 5x plus b squared. B is 5, so b squared is 25. And the term SOAP comes, if I start with a plus sign, the first sign is going to be the same. The second sign is going to be opposite. And the last sign is always positive. Same, opposite, always positive. And you can multiply to check. Okay, same thing with this one. This is a little bit harder. So I need a cubed is 27x cubed. So I need the cube root of 27. The cube root of 27 is going to be 3, meaning 3 multiplied by 3 multiplied by 3. 3 cubed is 27. So a is going to be 3x. The first sign is the same as what I have here, so I have a minus sign. The cube root of 8y cubed is going to be 2y, meaning 2y multiplied by 2y multiplied by 2y is 8y cubed. 3x squared, so that means I need to square this whole thing. So 3x multiplied by 3x is going to be 9x squared. Then I'm going to multiply these two together, but the sign here is going to be positive. So same as I started, opposite of what I started with. I'm going to multiply a times b. So 3x multiplied by 2y is going to be 6xy. And then I want b squared. So always positive. 2y multiplied by 2y will be 4y squared. And I know that multiplies out right, but you can always check by multiplying.